Paddy that isn't dried properly results in loss of quality and quantity of the grain. In this video, you will learn how to correctly dry your grain to help you reduce losses. First, let us look at why correct drying of paddy is so important. Then, we will offer some suggestions on optimum drying before we discuss the methods that would suit you best when it comes to drying grain. Why is it so important to dry paddy correctly? Rice is usually harvested at a grain moisture content between 24 and 26%. Delays in drying will damage your grain, reducing the quality and the quantity of that batch. If this occurs, you may notice yellowing or discoloration of the grain caused by mold development and heat buildup from respiration. Reduced milling yields because of cracked grain caused by high temperatures and rewetting of the grain. Loss of germination and vigor from grain respiration, mold and insect activities, or from exposure of grains to temperatures above 42 degrees Celsius. Damage caused by insects which are more active at higher moisture content levels. Here are some tips that can help you dry your grain more effectively and avoid this damage. You should dry paddy immediately after harvest, choosing the appropriate moisture content. For storage up to 2 weeks, dry grain to 18% moisture content. If you are drying paddy for milling, then dry to 14%. Drying to a lower moisture content reduces weight and milling yield. If you plan to store the grain for 8 to 12 months, dry to 13% or less. For long-term storage exceeding 1 year, dry to 9% moisture content. Always clean the grains before drying to avoid uneven drying and wet spots. Do not mix grain with different moisture content as this will cause the grain to crack. Always monitor grain temperature and moisture content to prevent excess temperatures and over-drying. Sun drying is the most popular drying method because of its low cost and ability to dry small batches of grain. It is labor-intensive, however, and control of grain temperature can be difficult. Paddy with moisture content below 18% can be slowly dried in storage bins using aeration with slightly preheated air of about 3 to 6 degrees Kelvin above ambient temperature. There are different capacity levels depending on the storage structure, so drying can take days or weeks depending on grain batch size. In-store drying produces good quality dried grain, uses low energy, and is more convenient to use. However, the drying time is long. Now, let us look at 3 types of heated air dryers. Farmers, contractors, and small rice mills regularly use a fixed bed batch dryer. The dryer's capacity ranges from 1 to 10 tons per batch with a drying time of 6 to 8 hours. The fixed bed batch dryer is simple to operate and cheap, with local versions available. However, drying may be uneven and it is labor-intensive. The recirculating batch dryer is best suited for rice mills and cooperatives. The dryer's capacity is 4 to 10 tons per batch. Drying time varies from 6 to 8 hours. The recirculating batch dryer results in even drying and is affordable. Its automatic operation, however, its mechanical components are subject to wear and tear. The continuous flow dryer is used by large commercial facilities. Its capacity is approximately 10 tons per hour. This dryer has a high capacity and automatic operation, but is capital intensive and requires large volumes of grain. Now, are you ready to dry your grain with a drying system that suits you best? Always remember to regularly monitor your grain temperature and moisture content for optimum results. In order to gain maximum returns from rice harvests, it is important to understand the different quality traits and how they are affected. Paddy or unhusked rice has a set of distinguishing qualities that can be measured to help prevent losses from occurring or continuing. In this video, we will show you what determines paddy quality and teach you how to measure each of its physical quality traits. Paddy or unhusked rice quality is influenced by a combination of varietal and environmental conditions, which occur during crop production practices, soil conditions, harvesting, and post-harvest practices. Some varietal properties include the color of the grain, the shape, size. Some important environmental properties determining paddy quality are moisture content, grain purity, physical and pest damage. Seven interrelated features determine the quality of paddy. These are moisture content of paddy, purity degree, varietal purity, grain dimensions, cracked grains, immature grains, and damaged grains. Now let's look closely at each characteristic. Moisture content of paddy, or the weight of water remaining in the paddy, is at its optimum milling potential at 14% moisture content. Grains with high moisture content are too soft to withstand hulling pressure without excessive damage. High moisture grains also deteriorate quickly in storage. Grain that is too dry becomes brittle and has greater breakage during processing, and if you sell over-dried grain, you get less profit due to excessive weight loss. Purity is related to the presence of material other than paddy and includes chaff, stones, weed seeds, soil, rice, straw, and stalks. Foreign matter in the paddy increases drying cost, reduces the milling recovery, the quality of rice, and increases the wear and tear on the milling equipment. A mixture of varieties causes difficulties during milling and usually results in reduced capacity, excessive breakage, lower milled rice recovery, and reduced head rice. The grain size and shape concerning the length-width ratio is a very distinct way to assess varietal property. In the rice mill, long slender grains normally have greater breakage than short, bold grains and consequently have lower mill rice recovery. Overexposure of mature paddy to fluctuating temperature and moisture conditions leads to development of fissures and cracks in individual kernels. Cracks in the kernel result in reduced milling recovery and head rice yields. The amount of immature paddy grains in a sample has a major effect on head rice yield and quality. The immature rice kernels are very slender and chalky and are easily broken during milling. Paddy deteriorates through biochemical changes in the grain, resulting in the development of off-odors and changes in the physical appearance and color of the grain. These types of damage are caused from water, insects, and heat exposure. Storing wet paddy or exposing dry paddy to wet environmental conditions can cause yellowing. Yellowing is a result of a combination of microbiological and chemical activity that overheats the grain, similar to a milled form of parboiling. Black spots around the germ end of the brown rice kernel are caused by the microorganisms or fungi and are increased by unfavorable weather or storage conditions. In the process of milling, these black spots are only partly removed, which consequently increases the presence of damaged or unattractive grains. When measuring the physical quality of paddy, there are 6 features to examine: cracked grains, grain dimensions, immature grains, dockage, 1,000 seed weight, and the moisture content. Let's explore how to measure each paddy quality trait in detail. Paddy will be classified based on International Organization for Standardization, or ISO, for paddy. This international standard lays down the minimum specifications for husked rice. Using the paddy crack detector, count the number of cracked grains in a 100-grain sample, then compute the percentage of cracked grains using this equation. The number of cracked grains divided by 100 grains. Then multiply this by 100 to get your percentage. To obtain the average length and width of the paddy grains, use a vernier caliper or photographic enlarger. Collect 20 paddy samples at random from each replicate and measure the dimensions. To obtain the paddy shape, the following equation will be used. The average paddy length in millimeters divided by the average paddy width in millimeters. First, select a 25-gram grain sample. Then select, segregate, and weigh the immature grains in the sample. Finally, calculate the percentage of immature grains in the sample using the formula: the weight of the immature grains divided by the total weight of the samples, and multiply this by 100. Remove light foreign matter, stones, weed, and seeds from a 100-gram sample. Next, obtain the total weight and then compute the dockage percentage as follows: weight of the dockage from sample divided by the total weight of the sample, and multiply this by 100. Count and weigh 1,000 grains. This will give you the 1,000 seed weight. There are two methods to measure moisture content: the oven method and the moisture tester. To measure moisture content using the oven method, use a temperature-controlled oven. First, set the oven to 130 degrees centigrade. Make sure the temperature is not higher than specified because chemical changes will occur within the grain which can cause additional weight loss. Step 2. Weigh 3 paddy samples and place them inside the oven. Step 3. Measure the final weight of the samples after 16 hours. Step 4. Compute the moisture content wet basis using this equation. Moisture content wet basis equals the initial weight of the paddy minus the final weight of the paddy. Divide this by the initial weight of the paddy and then multiply the result by 100 to get the moisture content wet basis for those samples. Step 5. Compute the average moisture content of the 3 samples by adding the equated moisture content of each sample together and dividing it by 3. To use a quick moisture meter, first read the operating instructions. Then check that the batteries are still good. Next, turn on the power and make sure the machine is set for paddy or rough rice. Then, fill the tray or bowl of the moisture tester with the paddy sample. Turn or press the knob until the moisture reading is displayed. It may take a little force, but make sure you turn the knob all the way as described in your manual, or you will get a wrong reading. Test at least 3 samples of the grain for an accurate moisture content reading. Those are the fundamentals of determining and measuring paddy quality. Be sure to follow each step carefully when measuring the characteristics, and remember, better quality grain equals better market value.